Good day, everyone. Today we are going to tackle about projectile motion. So what is projectile motion? Projectile motion. Galileo Galilei gives the most accurate description of bodies in projectile motion. He proposed that this type of motion occurs in two dimensions. The horizontal motion of a projectile is uniform and undisturbed, but due to the gravity of the body also travels vertically, with increasing velocity as it nears ground. The two dimensions or motions work on a projected object independently but together, causing the body to move in a curved path. He concluded that the path of a projectile or trajectory is a parabola. So what do you call the projectile or trajectory? It is a parabola. There are two cases of projectile motion. The first is horizontal projectile and the second is the angled projectile. To better understand what is horizontal projectile, I will show you a data. If we are going to graph that given data horizontally and vertically, distances in terms of time and motion, so we have, so the graph emphasizes several things for a body in ideal projectile motion. The horizontal acceleration is zero, thus the horizontal component of velocity is same at all times. The vertical acceleration is due to gravity having a magnitude of negative 9.80 meter per second squared. So the vertical component of velocity changes with time. The path traveled by the object is affected by its horizontal and vertical motions and is parabolic in nature. Now I will show you a table about the equation of horizontal projectile. I have here a sample problem about horizontal projectile. The sample problem is a pebble is thrown horizontally from the top of a 25-meter cliff and hits the ground 11 meters from the edge of the cliff. The question is, how long did it take the pebble to hit the ground? At what speed was the pebble thrown initially? What is the impact velocity of the pebble with the ground? Where is the pebble in 1.80 seconds after throwing it? To better understand the problem, so let us make a graph. Let us identify first what are the given. So the first is the y-axis, which is the negative 25 meter. Why negative 25? It is because paubo siya gi-throw ang pebble. The second given is the x-axis, which is 11 meter. First question is, how long did it take the pebble to hit the ground? So we are going to use the formula t is equal to square root of 2y over negative g. So t is equal to square root of 2 times negative 25 meter over negative 9.8 meter per second. So it will gives us, if we are going to multiply and divide that given numbers, it will gives us 2.26 seconds. So the time or the time traveled or the pebble hit the ground at 2.26 seconds. The second question is, at what speed was the pebble thrown initially? So we are going to use the formula. The initial velocity is equal to x over time. So initial velocity is equal to, the x is 11 meter over 2.26 seconds. So if we are going to divide that numbers, it will give us 4.867. So the initial velocity is 4.867. The third question is, what is the impact velocity of the pebble with the ground? So, we're going to use the formula velocity is equal to the square root of initial velocity plus gravity times time squared. So, it will give us velocity is equal to 22.7 meter per second squared. So, the impact velocity of the pebble with the ground is 22.7 meter per second. The last question is, where is the pebble at 1.80 seconds after throwing it? So we need to use two formulas in y and x axis. So in y axis, we need to use the formula g, which is the gravity, times the quantity of time squared over 2. So it will give us 15.9 meters. So in y-axis, the pebble, after 1.80 seconds, the pebble is in 15.9 meter. While on the other hand, in x-axis, we need to use the formula velocity or initial velocity times time. So it will give us 8.77 meter. Let us now proceed to the angled projectile. So in analyzing angled projectile is by using the expressions at specific positions on the path, like the greatest vertical distance, which is h, which h represents as height, maximum height, or the y maximum. And the greatest horizontal distance is x or the range. For this, we must see what happens to the projectile at the maximum height. So, at maximum height, the projectile is moving completely horizontally, suggesting that the y component of the velocity is 0. If it is so, then the expression will be velocity or Vy is equal to initial velocity sine theta minus gravity times time is equal to 0. This expression may be used to solve for the time to reach the maximum height or to rise, or the time rise. So, there is a formula in solving this. So, gt or gravity times time is equal to initial velocity sine theta. And time rise is equal to initial velocity sine theta over gravity. And if the distance of rise is the same as the distance of fall, then the total time of flight is twice the time of rise. So, the formula to be used is t, or the total time, is equal to 2 times initial velocity sine theta over gravity.